Imagine stepping outside and looking up at a sky that feels less like an atmosphere and more like a cosmic warning sign. The moment you tilt your head back, the world above you is not blue, not even close. Instead, it is a roiling canvas of darkness streaked with deep reds and glints of molten gold, as if the planet has not quite decided whether it wants to be a sky or a lava lamp. This is Earth during its opening act, long before continents, oceans, or anything resembling a peaceful afternoon. The air itself seems unsure of its job description. It hangs low and heavy, thick enough that every gust of wind feels like a volcanic exhale. You could stand there for hours and still not see the horizon clearly, because everything is blurred by a haze of fine particles drifting like ash from a fire that never goes out. Good evening. Curious minds, I truly hope you will enjoy today's video. Before we begin, leave a comment and tell me where and when you're tuning in. And if you find yourself learning something new as you drift towards sleep, consider subscribing, but only if you enjoy these calm journeys through the universe. Now, let's begin. In this early world, the sun is not the dependable, cheerful companion we know today. It rises like a bruised ember, dimmed by so many layers of haze that it barely earns the title light source. If the modern sun is a spotlight, this one is that flickering bulb in a horror movie that you absolutely know is going to go out at the worst possible moment. The sky swallows most of its brightness, letting through only a swollen orange smear. Daytime feels like living inside a half-lit furnace where the light seems tired, like it is struggling just to reach the ground. You could almost imagine the sun filing a complaint. I am trying my best down here, but this planet will not stop smoking. This haze is no gentle morning fog. It is a gritty, volcanic smog wrapped around the entire globe. The atmospheric equivalent of wearing sunglasses inside at night and insisting you can still see fine. The young planet is covered in vents and fissures that belch heat and minerals, not in polite plumes, but in roaring fountains of gas that spread upward and outward. Each eruption throws microscopic fragments into the sky that drift for days, sometimes weeks, tinting the air with a rusty glow. If you were standing there, you might look up and feel like the sky had texture, grainy, restless, always shifting. Every gust stirs it into new shapes, like an artist shaking a canvas between brushstrokes. There is something strangely mesmerizing about this alien sky. It pulses with heat and color, not in the gentle gradients of a modern sunset, but in bold, dramatic bands. Reds melt into blacks, golds into smoky grays. Some regions appear almost metallic, reflecting faint bits of sunlight, in the same way a freshly struck match might flare for a moment. It is beautiful in a rugged, dangerous kind of way, like admiring a storm from a safe distance, except there is no safe distance because the entire planet is the storm. You get the sense that early Earth was going through its rebellious teenage years, except this phase lasted tens of millions of years and involved far more magma. And yet, even in all this chaos, even with the sky looking like an abstract painting that takes itself too seriously, there is something undeniably captivating. You can almost hear the world humming, a low rumble from the shifting crust beneath your feet, mixing with the hiss of gases escaping into the air. The horizon glows faintly at times, not from sunlight, but from the constant geological upheaval. It feels less like a sky and more like the ceiling of a gigantic churning forge. Anyone witnessing this would probably think, yes, this planet is clearly under construction, hard hat required. The intense haze does more than distort the sun. It transforms the entire rhythm of the day. Without clear light, the line between morning and afternoon becomes guesswork. Shadows barely form because the sunlight is scattered in every direction, bouncing off particles as though the sky is trying its best to impersonate a dimly lit fog machine. That is why the joke practically tells itself. Earth's early sky came with its own atmospheric smoke machine long before concerts realized they needed dramatic flair. This smoky atmosphere also gives the sky a strange fluidity. Instead of the clean, crisp edges we expect today, everything blends together in gradients that shift as volcanic activity pulses. At times, the sky seems to throb with color, glowing faintly when new particles rise into the upper layers. You could almost imagine the sky breathing, slow, heavy, and uneven. The world feels alive in a literal sense, reshaping itself minute by minute. Nothing is settled, nothing is still. Standing in this world, you might feel like you are experiencing a version of Earth that few people ever imagine. It is not a world with gentle breezes or predictable weather. It is a sky that reflects the planet's raw personality as it begins its long journey toward stability. You are looking at the universe's idea of a dramatic opening scene, the kind of moment where a narrator would say, "In the beginning, everything was on fire, and frankly, it looked incredible." This chapter of Earth's past is more than just an alien sky. It is a reminder that our calm blue dome overhead is the result of billions of years of cosmic trial and error. But for now, we stay in this first billion years, a world where the sky itself feels unfinished, powerful, and unforgettable, like the planet practicing its first attempts at being a world worth living on. If you could bottle the atmosphere of early Earth and open it today, you would probably slam the lid back on faster than you would after sniffing a forgotten takeout container. This was an air mixture that seemed so confused about what a proper sky should smell like, look like, or behave like, that it functioned more like a cosmic chemistry experiment than anything breathable. Instead of clean, crisp oxygen or comforting nitrogen, the sky was stuffed with ingredients better suited for a giant planetary stew. Hydrogen and helium drifted lightly through the upper layers, leftovers from the planet's earliest moments. They floated so easily that Earth struggled to hold on to them at all, like a child trying to clutch fistfuls of balloons in a windstorm. Below those ephemeral gases, things grew heavier and stranger. Methane drifted in thick pockets, the kind that could turn the air translucent and give the entire atmosphere a warm, murky tint. This methane did not arrive through cozy biological processes or grazing animals. It came from deep chemical reactions within the crust, bubbling upward like the Earth was simmering under a planetary lid. Its presence helped tint the sky into a washed-out reddish brown, as though someone had smeared rust across the sky with a painter's rag. And then there was ammonia. If early Earth had a mascot, ammonia would probably be it. Sharp, pungent, and absolutely impossible to ignore. It reacted with sunlight in ways that filled the air with strange hazes, making the sky feel thick enough to touch. Imagine standing under a dome of swirling, chemically charged clouds that reflect light in muddy tones instead of crisp blues. You would look up and feel like the sky had been tinted by someone who misunderstood the concept of warm colors. To make things even more theatrical, volcanic gases were constantly venting into the atmosphere. They arrived not in polite little puffs, but in dramatic, overwhelming bursts. Volcanic exhaust carried a heavy mix of water vapor, carbon dioxide, sulfur compounds, and a chaotic assortment of metallic flavors. The world smelled like a laboratory that had exploded, but somehow still remained open for business. Every eruption injected new materials into the sky, thickening it, darkening it, and giving it a sort of primal intensity. The planet was not just wearing a haze, it was marinating in it. Standing on the surface, you would never mistake this sky for any version of Earth you know. When the sun attempted to shine through, the light bent and scattered in unpredictable ways. Shadows were muddled, as though everything was constantly being relit by a fading campfire. The reddish tone in the air made landscapes glow faintly on their own, creating a world that felt as if sunset had fallen and never left. It was a sky perpetually stuck between day and night, not out of poetic preference, but because the gases simply refused to cooperate. And the smell, oh, the smell. If modern air is a refreshing glass of water, this ancient atmosphere was more like standing in the steam of a dragon's unventilated shower. Every breath would deliver a potent blend of sulfur tang, ammonia sting, and methane haze. It would be the kind of inhalation that makes you question every choice that led you to that moment. Breathing this air, you would say, is like trying to inhale inside a dragon's bathroom. And you would not be exaggerating. You would also probably not try it twice. Yet despite the discomfort it would cause any modern organism with the audacity to breathe, this atmospheric recipe was a powerful sculptor. Each gas played a role in shaping how the sky looked, how heat was trapped, and how the surface began to cool or refuse to cool in different places. Methane, with its heat-trapping enthusiasm, helped keep the planet warm despite a dimmer sun. Ammonia absorbed ultraviolet light and helped spread that energy into the atmosphere. Hydrogen and helium occasionally escaped into space in dramatic swirls, leaving Earth surrounded by an evolving mix that changed almost as quickly as new volcanic eruptions appeared. The sky itself acted like a diffuser for sunlight, scattering it across dust and molecules that produced a murky, reddish glow. This was not the serene red of a peaceful sunset, but the kind of red you see when a light shines through dirty water. Up close, the air would look almost textured, layered with swirling pockets of gas that shimmered differently as the sun drifted across the sky. Clouds, when they formed at all, were patchy, unstable, and tinted by whatever chemicals were dominating the air at the moment. They might take on bruised purple hues, muddy browns, or even faint green tones depending on the reactions unfolding overhead. Even more dramatic were the events that occurred when sunlight managed to break through. The energy from the young sun did not politely illuminate the world. It collided with atmospheric molecules in ways that could trigger reactions, break apart compounds, and generate fleeting new gases. The sky was not just passive, it was reactive, constantly shifting like an artist who kept repainting the same canvas 20 times a day because they could not decide which version they liked best. In this turbulent atmosphere, Earth was still learning how to be a planet with a stable sky. The mixture overhead represented the raw ingredients of a world that had not yet figured out its long-term identity. It was a messy, fascinating stage, uncomfortable, unbreathable, and undeniably dramatic. Looking up at this early sky, you would not see a peaceful dome of blue. You would see chemistry in action, sculpting a world from the top down, using colors, gases, and swirling layers like strokes of a cosmic brush. This was the sky in its awkward first billion years, a sky that did not care about comfort or clarity, only about transformation. And as strange as it looked, it marked the beginning of everything Earth would eventually become. Picture standing on the surface of the young Earth during the Hadean era. The ground is still warm in places, the crust still cooling like a forgotten tray of cookies pulled too early from the oven. You barely have time to adjust to the heat before the sky reminds you that this planet is not done being dramatic. Overhead, the heavens are a battlefield. Meteors do not politely streak across the sky one at a time like they do during modern meteor showers. No, this is a continuous bombardment, a cosmic stampede of rock and metal that turns the atmosphere into a live-action light show. If modern meteor showers are sparkles, Hadean skies were a full-blown celestial stampede silently announcing, "Duck." The sheer frequency of impacts was astonishing. At any given moment, dozens of objects, from pebble-sized particles to mountain-scale monsters, blazed through the sky. Some skimmed the atmosphere, leaving sizzling trails that glowed like molten scratches across the darkness. Others arrived too fast, too hot, and too determined to be deflected. When they plunged downward, they dragged behind them tails of incandescent gas, bright enough to paint the ground in trembling shadows. The sky would flicker with golds, oranges, and blinding whites, like someone had poured fireworks into a blender and aimed the result at the planet. And when these objects hit the ground, they did not whisper. They detonated with thunderous force, kicking up fountains of molten rock that sprayed into the air and cooled mid-flight into glassy shards. These fragments sparkled as they fell, scattering like glitter from an angry cosmic parade float. The atmosphere filled with ash and dust, so fine it floated for days, sometimes weeks, blurring everything into a haze that shifted between smoky grays and faint reds. Each new impact added another layer of grit to the sky, turning it into a swirling soup of glowing particles and drifting debris. This was not just a sky you looked at. It was a sky you felt, rumbling through the ground beneath your feet, humming through the air around you. The impacts were so frequent that silence itself would have been a rare luxury. Shockwaves rolled across the landscape in overlapping waves, sometimes strong enough to whip loose stones into the air. The world trembled so often it likely felt as though it had a heartbeat, pulsing with every cosmic collision. If the Earth could have spoken during these early days, it might have said, "I'm still under construction. Please pardon the turbulence." Fragments that survive their fiery descent often ricocheted off the surface and split into smaller pieces, which continued their chaotic arcs through the sky before finally crashing down. Others vaporized completely, adding streaks of color to an atmosphere already oversaturated with light. Some of the larger incoming bodies generated shock-heated air that glowed blue or white, giving the sky brief flashes of brilliance bright enough to illuminate entire regions. These flashes were so intense they would have cast shadows even behind mountains. Between impacts, the dust drifting through the upper atmosphere created a dimming effect, muting the sun and giving the sky a bruised, smoky tint. Sunlight strained to break through, scattering across the particles in strange, unpredictable patterns. At times, the sky would look mottled, like an artist had splattered paint randomly across a canvas. At other times, it resembled a sheet of glowing ember-filled smoke, alive with the flicker of falling debris. This was a world where the concept of a night sky barely existed. The darkness above was constantly pierced by burning fragments tearing across it, leaving behind glowing trails that twisted and stretched as they cooled. Some streaks lasted long enough to drift slowly apart, like the fading strings of a firework that someone forgot to turn off. If you could have watched from a safe distance, which, to be clear, did not exist, this spectacle would have felt oddly festive. In fact, you might even joke that early Earth had the universe's most chaotic fireworks show, and no one was around to file a noise complaint. But beneath the spectacle, something profound was happening. Every impact stirred the young crust, mixing minerals, melting landscapes, and sometimes punching through to deeper layers. Each collision reshaped valleys, forged new basins, and cracked open regions that would later become part of continents. The bombardment even influenced the atmosphere itself. Each fiery descent injected heat, shock, and vapor into the air, altering the sky's chemistry and helping to sculpt the world's earliest environmental conditions. It was violence with purpose, destruction that made room for creation. The falling debris also added new materials to Earth's surface. Metals, minerals, and exotic elements from distant corners of the solar system rained down, embedding themselves into the crust. These ingredients would later become essential components of the rocks and resources the planet developed. Imagine the sky not only putting on a performance, but also restocking Earth like a cosmic grocery delivery service. If the delivery politely smashed through your roof every 5 minutes. Over time, the relentless impacts created a strange rhythm to life on the planet. Not biological life, but geological life. Heat built up beneath the crust, melted regions of rock, and sent plumes upward. The sky's constant barrage was not a random assault. It was part of a larger cosmic choreography that defined how early Earth matured. Each meteor strike was a drumbeat, each streak of light a reminder that the planet was still being shaped by the universe's heavy-handed tools. Walking under this sky would have been equal parts astonishing and terrifying. It was a world where the horizon glowed, the air buzzed, and the sky cracked open again and again with fire and stone. But buried inside that chaos was the earliest foundation of the planet we now recognize. The Hadean skies were not just dramatic. They were essential, fierce architects of a world still in its infancy. This was Earth in its rawest form, a planet being hammered into existence under a sky that never stopped blazing. Imagine a world caught mid-exhale, a planet still radiating away the heat of its violent birth, while water struggled to decide if it wanted to fall as rain, stay as vapor, or simply hover in a confused middle state like a pot that refuses to boil evenly. This was Earth during the era when the first oceans were attempting to form, a time when the sky was so choked with steam that it looked less like a sky and more like the inside of a giant celestial sauna. If you stood on the surface, preferably wearing heat-resistant boots and a heroic amount of optimism, you would see nothing above you except layer after layer of swirling gray mist, so dense and unbroken that clouds hardly seems like the right word. These were not friendly cotton shapes drifting lazily across the sky. These were colossal curtains of vapor wrapped tightly around the world. The steam came from everywhere. The surface still radiated heat, absorbed during the planet's molten youth, warming any newly condensed water enough to send it rushing back upward. Volcanic vents pulsed with hot vapor, releasing jets of moisture that instantly joined the swelling blanket overhead. Torrential rainfall hammered the ground, only for much of it to flash back into vapor before it could carve proper rivers. Every drop of water seemed to be caught in some cosmic identity crisis. The result was a sky so saturated with moisture that it behaved like a living, breathing entity, always shifting, always dripping, always muttering in the language of storms. Glancing upward, you would see nothing resembling the pale blues or vibrant sunsets we know today. Instead, the sky was an unbroken vault of muted gray, thick enough to hide even the faintest hint of celestial light. The sun, trying its best despite the circumstances, managed only to create a faint, soft glow, like a flashlight shining through a very damp blanket. Daytime had the same lighting energy as a half-forgotten basement lamp. Everything was illuminated just enough to navigate, but never enough to feel truly bright. You might glance upward, squint, and think, is that the sun, or a particularly stubborn patch of lighter fog? And on most days, you would not be able to tell. Temperatures swung wildly, depending on where and when the clouds thickened or thinned. Some regions became pressure cookers, trapping heat beneath the steam layer and creating climates that felt like walking inside a simmering broth. Other regions cooled rapidly when rain managed to fall in sustained sheets, only to heat back up again when that same water evaporated hours later. The entire planet operated like an unstable weather experiment, one that never submitted its lab report on time. The constant cycle of condensation and evaporation fueled storms that rolled endlessly across the globe. These storms were not brief outbursts, but marathon events that lasted for days, weeks, even months. Thunder rumbled through the mist in long, low growls, that echoed across landscapes still shaped by fresh geological scars. Lightning flashed only occasionally, its light diffused so thoroughly by the clouds that it appeared as brief pulses rather than sharp bolts. Every now and then the clouds thinned, just enough for the lightning to cast ghostly shadows, revealing fleeting silhouettes of mountains or ridges before everything vanished back into murk. Walking through this world would feel like wading through breath. The air held so much moisture that your skin would instantly feel clammy, as though the atmosphere had decided personal space was a concept it simply did not believe in. Visibility dropped to a handful of meters in many places. Everything beyond that melted into gray silhouettes drifting in and out of the mist. Even sound behaved strangely, muffled in some moments and amplified in others depending on how thick the steam layer was. Voices would not carry far, but the rumble of underground activity could travel in odd directions, making the ground feel alive. And those rare moments, those astronomically rare moments, when the clouds thinned enough for actual sunlight to break through, were almost mythic events. If you had been alive to witness one, you would have stopped whatever you were doing, stared upward in disbelief, and begun questioning your entire understanding of reality. A clear patch in the sky was not merely unusual, it was practically a cosmic miracle. Sunny days were as rare as a polite internet comment, and just as fleeting because the steam always rushed back, sealing the gap like the planet was embarrassed for letting too much light in. Despite the perpetual gloom, these steam-choked skies played an essential role in the planet's early transformation. The thick cloud layer helped regulate temperatures, preventing the surface from cooling too quickly. The constant rainfall slowly carved the earliest hints of basins where true oceans would eventually settle. The heavy vapor shield absorbed and scattered sunlight, reducing the intensity of ultraviolet radiation that would otherwise have battered the surface. In its overcast stubbornness, the sky was actually doing important work, less like a gloomy roommate and more like an overprotective guardian who insists on keeping all the windows closed. The forming oceans beneath this atmosphere were in a constant state of negotiation with the sky. Every drop of rainfall contributed to the slow accumulation of liquid water on the cooling crust. Every plume of steam rising from volcanic fissures fed moisture back upward to keep the cycle going. Over time, depressions in the land began filling more quickly than they evaporated. Pools turned into lakes, lakes merged into basins, and basins grew deeper and broader until they began to resemble the early outlines of seas. Above these forming waters, the sky continued its endless churn, a monumental engine powered by heat and moisture. Nothing remained still. Mist twisted in spiraling columns, clouds swelled like breathing lungs, and rain fell in shimmering sheets that disappeared into vapor before they struck the ground in some regions. In others, the rain actually succeeded in staying liquid long enough to gather and flow, shaping primitive channels and smoothing jagged rocks. This was Earth in its steamiest phase, wrapped in dense, rolling gray, living under a sky so thick and heavy it felt like part of the landscape. It was a world where light was a rumor, blue skies were fantasies, and every horizon was swallowed in mist. Yet this oppressive atmosphere was a crucial chapter in the planet's journey, a humid cocoon from which the first true oceans would eventually emerge. If you could time travel to the era when Earth's volcanic activity ran the show, you would not need a weather forecast. The daily outlook would always read, "Eruptions likely, ash guaranteed. Please avoid breathing." This was not a planet with occasional flare-ups. This was a world where volcanoes behaved less like isolated mountains and more like hyperactive pores in the planet's skin, releasing gas, ash, and molten fury in a near-constant symphony of geological enthusiasm. Everywhere you turned, the ground trembled with the low growls of magma moving beneath the crust. The air carried the metallic tang of minerals freshly hurled into the atmosphere. And the sky, oh the sky, looked as though the entire world had been placed under a volcanic Instagram filter set firmly to doom. Imagine waking up and looking out at a horizon that does not brighten with sunrise but instead remains shrouded in dark veils of drifting ash. These ash clouds were not polite wisps. They were towering gray fortresses rising miles into the upper atmosphere. Each eruption sent columns of pulverized minerals hurtling upward until they spread into massive fans that smothered sunlight with an almost artistic dedication. Daytime did not arrive in golden rays. It seeped in dimly through layers of airborne grit, giving the world a muted glow, as if the sky itself had forgotten how to turn its brightness settings up. The frequency of these eruptions made the sky feel like a constantly rewritten story. At one moment, the horizon might be choked by thick, roiling ash that turned everything charcoal black. Minutes later, a new eruption miles away could send plumes of copper-tinted dust drifting in, coating the air in a warm, ominous haze. The sky never looked the same from 1 hour to the next. It shifted between smoky grays, volcanic reds, and sepia-toned yellows, all blended by wind patterns that swirled the ash into long ribbons stretching across the dome of the world. If anyone had been alive to witness this spectacle, they might have said the atmosphere resembled a moody art student's portfolio, dramatic, textured, and very committed to its aesthetic. But the visuals were only part of the experience. The soundscape of this volcanic superatmosphere was relentless. Eruptions boomed like distant thunder, their echoes rumbling across the landscape in long, rolling waves. The earth cracked and hissed as gases escaped through vents that peppered the crust. Occasionally, pressure built so intensely inside a volcanic chamber that it burst with a sound sharp enough to momentarily silence the world. The atmosphere carried these noises in strange, distorted ways, bending them around ash clouds so that distant eruptions could sound closer than nearby ones. The planet was an orchestra, tuning itself violently with percussion that never stopped. And then there was the fallout. Ash fell from the sky in a constant drizzle, sometimes as fine as flour, sometimes in clumps that drifted like dark snowflakes. The particles coated everything: rocks, forming soil, cooling lava flows, with a gritty layer that shifted underfoot like powdered stone. In some areas, ash piled so quickly that it buried young landscapes, creating thick blankets that reshaped contours and filled depressions. The air carried so much particulate matter that visibility dropped to narrow corridors of smoky gray. The world felt condensed, as if wrapped in layers of volcanic breath. The effects on sunlight were profound. Ash particles were masters at scattering and absorbing light, which meant that even during periods of intense solar brightness, the world beneath the clouds remained dimmed. Shadows blurred into the general gloom, and the sun appeared not as a distinct circle, but as a vague glowing patch behind curtains of drifting dust. The atmosphere softened every edge, making mountains, valleys, and even erupting volcanoes themselves look like silhouettes fading in and out of existence. This was not merely a darkened world. It was a filtered one, with nature pulling all the dramatic levers. Earth basically lived inside a volcano's Instagram filter set to doom, and it wore that aesthetic proudly. Yet beneath the apocalyptic mood lighting, these volcanic emissions were shaping the planet in essential ways. The gases released, including carbon dioxide, sulfur dioxide, and a host of trace chemicals, contributed to atmospheric reactions that would eventually influence temperature, cloud formation, and even early chemical pathways on the surface. The heavy veil of ash helped reflect some incoming sunlight, cooling certain regions, while the greenhouse active gases trapped heat in others, creating a patchwork of climates that varied wildly across the globe. Volcanic minerals rained onto the surface and dissolved into forming waters, enriching them with ingredients that would later become indispensable for chemical evolution. The plume-laden sky also served as a mixing bowl for countless reactions. Sunlight that managed to break through scattered across ash particles, creating halos and faint glows around suspended dust. Sulfur compounds interacted with atmospheric moisture to produce droplets that contributed to thicker and more resilient cloud layers. Even the temperature gradients caused by rising and falling ash plumes generated fierce winds that shuffled gases across vast distances. The sky was not just a passive canvas, it was an active, roiling laboratory, and the eruptions themselves varied in personality. Some were explosive, hurling ash into the air with such force that it spread globally. Others bled lava steadily, releasing gas in slow, steady exhalations that thickened the sky over time. Entire regions glowed with the light of molten rivers after nightfall. Not that nightfall made the sky any darker, and steam mixed with volcanic chemicals to create drifting fogs that smelled faintly of minerals and heat. In this chaotic atmosphere, the world felt both expansive and claustrophobic, wide open yet constantly obscured. This volcanic chapter of Earth's story was not gentle or quiet, but it was essential. The sky during this era was a testament to a planet still forging its own identity, sculpting its surface and atmosphere one eruption at a time. It was dramatic, unpredictable, and undeniably mesmerizing. A world living under the constant shadow of its own fiery creativity. If you ever wished for a front row seat to the universe's most dramatic weather performance, the early Earth would have handed you a ticket and a complimentary helmet. This was a planet whose sky seemed determined to conduct electricity like it was auditioning for the role of cosmic power grid. Lightning did not wait patiently for storms to gather. It erupted constantly, dancing across the sky in jagged white arcs that split the darkness and stitched it back together again and again and again, until the whole sky pulsed with energy. The atmosphere during this era was so charged, so restless, and so chemically primed for electrical tantrums that lightning struck so often it was like the sky was speed-running electricity just to prove it could. To understand why lightning held such a starring role, imagine the atmosphere as a colossal mixing bowl filled with churning gases, drifting ash, and particles that refused to stay still. Volcanic eruptions pumped massive quantities of ash upward, and these sharp little dust grains collided with one another constantly. Each collision transferred tiny bits of electrical charge, separating positive and negative particles, the way rubbing a balloon on your hair makes it stick to the wall. Except instead of being cute party physics, this was the sky building a powerful, explosive grudge. The taller the volcanic plumes climbed, the more these charges accumulated. Eventually, the atmosphere became electrically loaded, like a sweater straight out of a dryer, but scaled up to planetary proportions. The result? Lightning storms that made modern thunderstorms look like lukewarm rehearsals. Bolts forked across the sky in sprawling webs, illuminating entire regions with blinding flashes. Some bolts stretched horizontally for astonishing distances, crackling like luminous scars written across the cloud layers. Others plunged downward, striking the ground with enough energy to melt sand into glass on the spot. To anyone watching, assuming anyone could survive long enough to do so, it would seem as though the sky had decided it was not enough to be dramatic. It wanted to be loud, bright, and constantly in motion. Each lightning strike carved a momentary snapshot into the darkness, revealing landscapes that looked sculpted from shadow, jagged ridges, cooling lava fields, and swirling columns of ash that appeared frozen in time for a fraction of a second. Then darkness swallowed everything again, only to release another reveal a heartbeat later. It was a world lit by strobe light logic, where scenes unfolded in sharp, brilliant flashes rather than continuous daylight. Walking across this planet would feel like taking steps through a cosmic photo album that kept being updated by electricity. But the show overhead was not just aesthetic, nor simply violent. It was transformative. Every lightning bolt carried enough energy to break apart molecules floating through the air. Ammonia, methane, and other components of the early chemical stew were blasted into fragments that recombined into new, more complex molecules. Some of these reactions produced building blocks that would later play a part in the chemistry of life, making early Earth one of the most accident-prone chemists in the cosmos. Imagine lightning bolts functioning like enormous, impatient mixers, whipping the atmosphere into elaborate recipes with absolutely no regard for safety guidelines. The storms themselves were not uniform. Some formed towering systems that spanned enormous stretches of sky, flickering internally like lanterns trapped inside gray fortresses. Others were smaller but more frequent, bouncing from one volcanic region to another as pockets of ash drifted and merged. Winds churned unpredictably through these systems, sometimes accelerating particles enough to energize them even further. the sky became an arena of constant collisions, ash hitting ash, gas hitting gas, charge building upon charge, until the inevitable explosion of light erupted again. Thunder followed with a personality all its own. Because early Earth's atmosphere was so dense with particles, thunder did not always travel cleanly. Sometimes it rolled in long, deep rumbles that literally shook the ground as the vibrations resonated through layers of mist and dust. Other times, it cracked sharply, bouncing unpredictably as sound waves ricocheted through uneven pockets of air. The planet frequently echoed with overlapping booms and growls, creating a soundscape that felt ancient, primal, and thoroughly unwilling to be ignored. And beneath these persistent storms, the ground was constantly transformed. Lightning that struck mineral-rich surfaces could trigger chemical reactions that fused elements in unusual ways. In some regions, repeated strikes etched channels or melted patches of rock. Pools of water warmed by geothermal heat were often electrified by nearby bolts, turning them into spontaneous reaction chambers. It was as though nature kept throwing energetic darts at anything that might react, experimenting with endless combinations just to see what would form next. The sky during this era seemed almost eager to participate in every aspect of the planet's transformation. Instead of being a passive dome overhead, it acted like a conductor directing a chaotic but purposeful orchestra. Storm clouds formed quickly, collapsed dramatically, then reformed with renewed intensity as ash from new eruptions fed them fresh fuel. The constant movement prevented any long-term clearing of the skies. Darkness and light flickered in relentless cycles, giving the world a rhythm defined by electricity rather than sunshine. Even the colors of the storms were unique. The clouds often glowed faintly from within, illuminated by countless micro-discharges that never reached full lightning strength, but shimmered like static patches of ghostly light. The edges of clouds took on strange bluish or purplish hues whenever lightning branched near their surfaces, tinting the sky in shades that would look unreal today. At times, the entire horizon pulsed gently as distant storms traded electrical volleys back and forth, like the planet was quietly debating with itself through bursts of plasma. This electrically saturated world was, without exaggeration, one of the most dramatic atmospheric stages Earth has ever hosted. It was wild, unpredictable, and mesmerizing, a time when lightning ruled the sky with absolute confidence and zero interest in subtlety. If modern storms are thunderstorms, early Earth hosted thunder universes, vast, unending networks of charged chaos that shaped the planet from above. Lightning was not just weather, it was a planetary sculptor, a chemical catalyst, and the sky's loudest expression of energy. And in those early days, it struck with such speed and enthusiasm that the sky truly looked like it was speed-running electricity, racing through millions of bolts as if competing for some cosmic high score. There comes a point in every planet's life when it decides to calm down just a little, and early Earth was finally entering that stage. The ground, once a chaotic patchwork of molten rivers and eruptive scars, began settling into something that resembled stability. Oceans that had previously spent their time evaporating, raining, and re-evaporating in an endless loop finally started to stick around. Water pooled in the great basins of the cooling crust, deepening into actual seas instead of temporary puddles. The atmosphere above these expanding bodies of water began to respond, shifting in texture and color in ways that would have seemed miraculous after the gloom and fury of earlier ages. The sky, which had been a smoky workshop of ash, steam, and lightning, started slowly revealing hints of gentler light, like a stage whose curtains were lifting cell by cell. As the oceans stabilized, they became powerful regulators of atmospheric temperature. The planet was still warm, certainly, but not in the everything is actively melting sense. Heat moved more evenly across the surface, carried by winds that flowed over thickening waters instead of superheated plains. This subtle redistribution of warmth began altering how sunlight filtered through the sky. With less ash hanging around, and with steam no longer forming suffocating blankets quite as often, the light could finally stretch its legs. It passed through cleaner layers of atmosphere, shifting the sky's palette away from the harsh, rusty tones that had dominated for ages. Those deep red hues began to soften into coppery gradients, warm and metallic, yet far less oppressive than before. Every dawn painted the world in shades that looked rich and molten, like the sun had turned into a giant forge, but decided to keep things tasteful. The evening skies followed suit, glowing with subtle purples that shimmered across the horizon. These tones emerged not because the world suddenly wanted to be pretty, but because light was finally interacting with a calmer atmosphere, one with fewer suspended particles and more stable gases. Molecules that had previously been obscured by chaos now scattered sunlight in new ways, letting wavelengths slip through that had never truly been visible on Earth before. Anyone witnessing the transformation would have sworn the planet was experimenting with its personal style. One day, the sky resembled hammered copper. The next, it looked brushed with lavender mist. The world seemed to be asking itself, am I more of a warm palette or a cool one? For a moment, Earth looked like it was trying out a new aesthetic phase, the kind of dramatic rebranding you might expect from a teenager who suddenly decides they are into vintage photography. Except Earth's version involved entire oceans, atmospheric chemistry, and the glow of a still young sun. Part of this visual shift came from the changing interactions between sunlight and moisture. With oceans stabilizing, evaporation became more predictable. Clouds formed in patterns rather than in chaotic bursts. These clouds were thinner than their storm-drenched predecessors and more delicate in composition, allowing light to refract and reflect in softer spectrums. The sky still cycled through storms, but the storms no longer ruled every waking moment. Between them were gentle spans of calm, where the atmosphere revealed its new palette without being swallowed by steam. The ground contributed as well. As the crust cooled, it released fewer superheated gases, which meant the air was no longer constantly infused with sharp volcanic compounds. Instead, the atmosphere held a more even balance of early gases, creating a more stable scattering environment for sunlight. Fewer particulates meant light did not get muddied into deep, dark tones. Instead, where rust-colored skies once reigned, there now appeared softer metallic shades that slipped into subtle violets and dusty pinks as the sun moved toward the horizon. These changes created a sky that felt less like a warning sign and more like a painting in slow motion. Each day offered new blends, copper fading into mauve, burnt orange descending into twilight purples, or a muted gold that rippled across the water's surface during midday. The oceans themselves amplified the effect. Their wide reflective expanses bounced warm tones into the clouds above, turning the sky into a huge atmospheric mirror that gently echoed its own evolving colors. Even the texture of the sky shifted. Instead of appearing grainy with dust or blurred by dense vapors, the air took on a smoother, more cohesive quality. Light dispersed in soft gradients, fading evenly rather than abruptly. Horizons became clearer, and distant landforms, once smothered in haze, began to emerge, outlined by atmospheric layers that no longer fought to obscure everything. It was the visual equivalent of the planet finally taking a deep breath and letting its shoulders relax. But this new aesthetic phase was not merely cosmetic. These more stable atmospheric conditions hinted at a planet slowly preparing for a new chapter. The oceans, now anchored rather than ephemeral, began moderating temperatures across vast distances. Winds followed predictable paths, shaping climate patterns that were still wild by modern standards, but no longer entirely chaotic. Sunlight reaching the surface with more reliability allowed chemical processes to evolve in ways impossible under constant atmospheric turmoil. Yet the sky remained expressive. It had not traded drama for dullness. It had simply discovered nuance. Copper dawns transitioned into warm, hazy afternoons, where the sun glowed like a softened ember. Twilights shimmered with violet shadows that stretched across the surface, like brushstrokes from a cosmic artist trying out new pigments. Every shift signaled the gradual stabilization of the world below and the atmospheric experiments happening above. Looking up during this period would have felt like witnessing a planet learning self-control, still intense, still volatile beneath the surface, but increasingly capable of moments of quiet beauty. The sky was no longer a battleground of fire and shadow. It was an evolving canvas, experimenting with elegance, playing with light, and discovering the first whispers of color that would one day lead to the full-spectrum skies we now take for granted. In this chapter of Earth's story, the atmosphere was not yet blue, but it was undeniably becoming expressive. This was the world practicing color theory, long before life had eyes to admire it. There comes a quiet turning point in Earth's early history when the atmosphere, after ages of behaving like a hyperactive cauldron, finally begins to develop something resembling a rhythm. This was the era when water vapor cycles strengthened into a dependable pattern, and the sky, still moody, still dramatic, started showing hints of stability for the first time. Imagine a world where clouds no longer appeared only as byproducts of chaos, but instead formed with enough regularity that someone might have called them weather rather than sky-based panic. Those early clouds were far from gentle pillows of white, but compared to the choking steam curtains and endless volcanic plumes that came before, they were downright civilized. The heart of this transformation lay in the newly established oceans. Their surfaces warmed under the sun and exhaled water vapor in steady streams, sending moisture into the lower atmosphere with a calmness that would have been impossible during earlier, more explosive ages. Instead of violently erupting into the sky through desperate geysers of steam, water now rose in a smooth, widespread lift, carried upward by winds that were beginning to adopt predictable patterns. This consistency allowed the atmosphere to develop layers, actual layers, where moisture collected and cooled, forming clouds that drifted rather than spiraled. These early clouds were dense and heavy-bodied, the kind that cast broad shadows even during the weak sunlight of the time. They tended to form in vast sheets that moved across the horizon with a stately purpose rather than appearing in frantic bursts. Their bases were thick and dark, but their tops softened into gentler whites and muted grays, a sign that the atmosphere was slowly learning the art of subtlety. On some days, when conditions aligned just right, the clouds pulled apart in patches, leaving pockets of open sky, pale, washed out, and fleeting, but open nonetheless. These were the first blue sky teasers, like movie trailers for a film that would not premiere for hundreds of millions of years. Those little windows of clarity must have been astonishing in contrast to the world's long history of atmospheric overbearing. When sunlight found a gap, it poured through in sharp beams rather than diffused glows. The surface briefly lit up in ways that made rocks and water shine with an unfamiliar crispness. For a moment, colors seemed sharper, shadows more defined. Then, as if the sky realized it had revealed too much too soon, the clouds drifted back into formation and sealed the view again. The planet was not ready for a blue sky era, but it was happy to hint at one. The cyclical nature of evaporation and condensation helped enable these atmospheric previews. As water vapor rose and cooled, it condensed into droplets that gathered into cloud masses. When the droplets grew heavy, they fell as rain, not the chaotic, scalding rainfall of earlier epochs, but gentler, more coordinated showers. These rains refreshed the oceans, cooled the surface, and reset the cycle in a loop that became more consistent with every passing millennium. The planet was beginning to adopt a hydrological beat, a steady inhale and exhale of moisture that led to increasingly stable skies. Of course, storms still dominated much of the world. This was not a serene weather paradise by any means. Thunderstorms formed with dramatic speed when hot air rose from volcanic regions or when dense clouds collided. But the storms were no longer the planet's default state. They were interwoven with calmer stretches, giving the sky a texture that felt, for the first time, complex rather than purely chaotic. A day might begin with heavy clouds, open briefly into a soft haze of pale sky, then shift into a rumbling downpour. It was variability with pattern, turbulence with structure. Earth was discovering its rhythm. Even the shape of clouds changed over time. Instead of being shapeless veils of moisture or towering columns formed by violent updrafts, clouds developed edges, actual outlines. Some stretched long and thin across the horizon, creating subtle bands that resembled brushstrokes of gray. Others gathered into rounded masses that hinted at the shapes of modern cumulus clouds, though still heavier and darker. The atmosphere was experimenting, crafting the early prototypes of cloud forms that would later become familiar. Beneath these evolving skies, the oceans played a quiet but profound role. Their dark surfaces absorbed sunlight, warming slowly and steadily instead of fluctuating wildly. This moderation reduced the thermal extremes that once fueled constant storms. Winds became more organized, helping clouds travel along sweeping routes rather than being jumbled randomly by endless turbulence. For the first time, the sky had corridors, zones of calmer air where clouds could drift peacefully and visibility could stretch farther than a stone's throw. The clearer intervals, while rare, allowed sunlight to interact with the atmosphere in new ways. Rays gained enough clarity to produce faint color shifts, softening the once metallic tones of the sky into mild gradients. At certain angles, the atmosphere took on a faint bluish tint, weak and washed out but unmistakably present. It was a preview of the future, a whisper of the vibrant sky Earth would one day claim. The air also began feeling different. With fewer volcanic impurities clouding the atmosphere, the texture of the sky grew smoother. Moisture became the dominant sculptor, shaping how clouds formed and how light passed through them. Even temperature gradients became more forgiving. Instead of abrupt swings, the day warmed gradually and cooled gently, helping the cloud layers remain intact for longer stretches. This newfound stability was the backbone of the planet's climatological evolution, a hint that Earth was no longer merely reacting to chaos, but beginning to orchestrate its own environmental composition. And through all of this, the sky looked like a world in transition. Not yet the brilliant blue we know, but no longer the darkened, ash-stained vault it had been. It was softer, calmer, and occasionally, unexpectedly, beautiful. As the clouds opened in fleeting moments, those pale blue previews must have felt like promises from a world learning to breathe in a calmer rhythm. The film was far from ready, but the trailers were rolling. Imagine looking up at a sky that is not just a passive backdrop, but a full-blown laboratory, constantly mixing, heating, breaking, and rebuilding molecules in a frenzy of chemical creativity. This was the state of early Earth's atmosphere, when sunlight was not simply illumination, but fuel, raw ultraviolet firepower crashing into gases and transforming them with the enthusiasm of a chef who throws ingredients into a pot just to see what happens. The difference here was that the pot was planet-sized. The ingredients were ancient gases swirling high above the surface, and the heat source was a young, energetic sun. The sky was basically running a cosmic crockpot on high heat, bubbling through reactions that would have baffled even the most imaginative chemist. At this time, the atmosphere held a cocktail of gases left behind from volcanic activity, planetary cooling, and lingering traces of primordial chemistry. There were molecules like methane, carbon-containing compounds, drifting through the air in thin veils. There were nitrogen-based gases, energy-hungry and reactive in ways that made them prime candidates for transformation. Water vapor from the stabilizing oceans rose and fell in pulses, bringing humidity into regions where sunlight could slam into it with unfiltered intensity. This collection of ingredients did not float gently. They collided constantly, shuffled by winds, heated by radiation, and stirred into clouds that acted as mobile mixing chambers. The sunlight reaching Earth was far stronger in ultraviolet wavelengths than it is today because the protective ozone layer had not yet formed. That meant every ray of UV light carried a fierce sharpness, like a row of invisible chisels chipping away at molecules. When ultraviolet photons struck methane, they split its atoms apart, leaving fragments that darted through the atmosphere like eager puzzle pieces looking for new partners. Nitrogen and hydrogen compounds were torn open as well, their bonds snapping in bursts of microscopic drama. Even water vapor wasn't safe. Sunlight sometimes ripped it apart into its elemental components, releasing hydrogen that drifted upward and oxygen that sought out opportunities to bind with other gases. These broken fragments did not stay lonely for long. They recombined with whatever passed nearby, forming molecules that had never existed on Earth's surface before. Some became thick, sticky organic hazes that gathered into the upper atmosphere like a veil of microscopic soot. Others linked together into more complex chemical structures, rudimentary organic compounds that represented the earliest hints of molecular chemistry heading in the direction life would eventually follow. It was as if the sky kept tossing ingredients together to see what stuck, stirring them with sunlight, then letting the results drift downward for the surface to digest. As these reactions occurred, the sky itself began to reflect their presence. The hazes formed from carbon-rich compounds started tinting the atmosphere with soft, diffuse colors, not the copper and lavender shades of earlier atmospheric shifts, but something more mysterious, tones that wavered between amber, gold, and faint violet, depending on how thick the haze became and how the sunlight filtered through it. Some days the sky appeared washed with a pale, smoky gold that glimmered above the horizon. On others, the haze thickened into deeper, richer hues, giving the heavens a subtly oily sheen, as though the air itself held suspended droplets of shadow. This haze did more than influence color. It began to act as a partial sunshade, absorbing ultraviolet radiation and softening the harshness of direct sunlight. The atmosphere became layered, with the upper levels filled with actively reacting molecules, and the lower levels growing calmer as the haze shielded them. Each layer hosted its own set of reactions, its own microclimates, and its own distinct chemistry. Sunlight breaking through the haze scattered in new ways, sometimes giving the sky a muted glow, and sometimes making it appear dimmer than the sun's true brightness would suggest. But the real magic happened where ultraviolet radiation met the densest pockets of organic molecules. In these regions, complex chains formed, nothing alive, nothing structured enough to be considered life's early ancestors, but certainly a step toward more sophisticated chemistry. Imagine millions of tiny reactions happening simultaneously, each forming something transient, or unstable. Some of those molecules fell apart instantly. Others lingered long enough to drift downward, eventually landing in oceans or pools where different conditions awaited them. The sky, in this sense, was not just creating chemistry, it was exporting it. Thunderstorms added even more energy to the mix. Lightning bolts, still abundant though less relentless than in earlier epochs, sliced through hazy air and provided sudden bursts of electrical energy. These electrical surges welded atoms together in ways sunlight alone could not achieve. The combination of lightning spark and ultraviolet radiation's steady hammering created a lively, overlapping system of reactions that spread across the atmosphere like invisible fireworks. Even wind patterns played their part. As the planet continued to cool and oceans helped stabilize temperatures, air currents began circulating more predictably. These currents carried freshly formed molecules from one side of the globe to another, allowing chemical populations to intermingle. Regions rich in methane might mix with zones dominated by nitrogen compounds, creating brand new reaction possibilities. In some places, upper-level hazes thickened into full chemical blankets that drifted slowly across the planet's surface. In others, the haze thinned just enough to let hints of soft light filter through. The surface beneath these atmospheric experiments often reflected the sky's changing tone. Seas glimmered with faint colors cast by the hazes overhead, turning waters metallic or dusky depending on the hour. Land masses shimmered slightly as sunlight bounced through layers of haze before reaching them. Even shadows looked different, sometimes elongated and feathered at the edges, sometimes strangely muted. Throughout all of this, the sky never stopped conducting its grand experiment. It kept mixing gases, breaking bonds, forming new ones, and sending its molecular creations drifting across the planet like tiny chemical ambassadors. In many ways, it was Earth's first laboratory, massive, uncontrolled, but astonishingly productive. Though still wild and unpredictable, this chemically charged sky marked a quiet turning point. It represented the planet's shift from raw geological fury to intricate atmospheric chemistry, a hint that the world was starting to develop the ingredients needed for the next great transformation. A transformation that would eventually involve life, but for now, the sky simply kept stirring its cosmic crockpot, simmering reactions that would echo through the ages. There is a moment in Earth's history when the atmosphere, after billions of years of being sculpted solely by physics, chemistry, and geology, encountered a brand new interior designer, life, and it did not wait politely to be introduced. As soon as the first microbial communities found ways to survive in the oceans, they wasted no time in sending subtle but profound ripples upward into the sky. These early microbes were tiny, almost unimaginably tiny, but their impact stretched all the way into the atmosphere, like enthusiastic tenants redecorating the entire building. Life showed up early and immediately started rearranging the furniture. Before oxygen became the celebrity molecule it would later become, microbial life had other tricks up its sleeve. Many of the earliest organisms fed on the chemicals drifting through the oceans and atmosphere, using them like cosmic groceries left unattended. Some consumed carbon-based molecules, breaking them apart and releasing byproducts that floated upward. Others took in gases like hydrogen or sulfur compounds and returned different gases back into the environment. These exchanges didn't produce dramatic bursts of color or sudden sky-shattering events. Instead, they introduced careful nudges, persistent, quiet, transformative nudges into the atmosphere's chemistry. One of the first major changes these microbes made was to reduce the thickness and character of atmospheric hazes. Before biology entered the scene, hazes formed purely from photochemical reactions, ultraviolet radiation hammering methane and other molecules until they assembled into drifting organic smog. But early life began nibbling on the very ingredients that fed those hazes. Some microbes consumed methane, trimming the supply of one of the atmosphere's favorite haze-building molecules. Others produced compounds that subtly interfered with how organic particles clumped together. As a result, the upper atmosphere gradually shifted from an opaque blur to a thinner, softer haze, one that allowed light to filter through in new ways. The result was a sky that began to change color, not suddenly, not dramatically, but with the kind of slow transition you might notice only after stepping outside one day and thinking, "Has that always been that shade?" The golden and violet tones of earlier epochs softened into paler washes. The air looked clearer at certain angles, less like a veil and more like a lightly frosted window. Sunsets, for the first time, developed hints of gentle gradients rather than blunt monotones. The sky was still far from blue, but it was moving in that direction, inch by inch, molecule by molecule. Microbes also influenced the atmosphere through the gases they exhaled. Many early organisms released carbon dioxide, or nitrogen-rich compounds that altered the balance of atmospheric chemistry. Others emitted gases that participated in complex chain reactions, which in turn influenced what kinds of particles floated in the air. The atmosphere became a sort of conversational space where gases introduced by life interacted with sunlight and minerals, generating new blends of molecules not previously seen. This gave the sky a slightly different texture, one that reflected light with more subtlety, one that changed more gradually across the day. In regions where microbial mats formed near shorelines or across shallow seas, changes in the sky could be observed more directly. These vast, carpet-like communities processed dissolved minerals and gases in the water beneath them, and their metabolic leftovers escaped into the air. Over long stretches of time, certain patches of the sky developed faint but noticeable differences in hue. Above areas rich with microbial activity, the haze sometimes thinned just enough to let the atmosphere take on a less opaque tone. In effect, life was tugging at the curtain that had long covered Earth's true sky. These microbial pioneers also helped regulate the supply of greenhouse gases, though not intentionally. By consuming or producing various molecules, they influenced how much heat the atmosphere could trap. In places where methane was reduced by microbial metabolism, the local climate cooled slightly, altering how moisture moved and how clouds formed. These shifts created small atmospheric pockets where the sky looked clearer or brighter than in surrounding regions. Earth was still a world governed by extremes, but life had begun introducing nuance to its moods. Another subtle atmospheric transformation involved the tiny particles on which clouds form. Some microbial byproducts made excellent seeds for cloud droplets. When these compounds drifted upward, they encouraged the formation of small, wispy clouds. Nothing dramatic, nothing thick, but enough to slightly influence how sunlight scattered. On certain days, the sky gained hints of softness, edges blurring just a little more delicately than they had before. Life had not yet mastered the art of cloud choreography, but it was filing the paperwork. Even the smell of the atmosphere began to change. Though no human nose was there to notice, the air carried hints of compounds generated by microbial metabolism, subtle traces of sulfur, nitrogen, and organic vapors that never existed in the air before life emerged. These molecules contributed to atmospheric reactions capable of adjusting the haze thickness and influencing how light refracted at different altitudes. The sky began to take on a faintly organic signature, as if the planet were breathing in a new way. Despite their tiny size, these microbial communities were relentless. Every cycle of growth, every metabolic reaction, every molecule consumed or released contributed to a tiny push in the direction of atmospheric evolution. It was a slow accumulation of small gestures, each almost imperceptible on its own, but together they created a meaningful shift. The atmosphere was no longer a purely chemical construct. It was a hybrid, a collaboration between geology, sunlight, and the handiwork of microscopic life. And through all these subtle changes, the sky began showing hints of becoming more transparent. The dimness of earlier eons gradually lifted. The world brightened, even if only slightly. The air felt less clogged with murk, more open, more willing to let the sun speak clearly. Life had, in its tiny, earnest way, begun tidying up the place, not for decoration, not for comfort, but because that is simply what microbial metabolism does. Long before oxygen took center stage and transformed the sky into something truly luminous, these early life forms had already cracked open the door. They had begun pushing the planet toward a different future, one where the atmosphere would no longer be dominated by haze and shadow. The sky, under their influence, started its slow but steady journey toward clarity. Life had entered the scene, and the sky would never again be merely the realm of chemistry alone. There comes a moment in every grand planetary saga when a character enters so quietly, so hesitantly, that no one realizes at first how completely it will reshape the entire storyline. For Earth, that character was oxygen. Not the confident atmosphere-dominating gas we breathe today, but the earliest, most bashful traces, barely measurable, barely noticeable, and yet already nudging the atmosphere toward its next identity. Oxygen was the shy kid at the party, barely speaking but changing the vibe anyway. For ages, Earth's air consisted of gases that behaved predictably under sunlight. They absorbed and scattered light in ways that maintained the hazy, muted sky established long before life's chemistry began to meddle. But as photosynthesizing microbes emerged, tiny organisms quietly using sunlight to split water and stitch together carbon, they began releasing small whispers of oxygen as their metabolic leftovers. At first, these oxygen molecules met a swift and unceremonious fate. They reacted with minerals, metals, and gases that lay in wait, gobbling them up before they had a chance to accumulate. Iron in the oceans eagerly captured oxygen, turning entire seas rusty in the process. Volcanic gases snapped it up as well, binding oxygen into compounds that sank or drifted away. It seemed impossible that such a reactive newcomer would ever rise to prominence. But oxygen is persistent. And the microbes producing it were wildly successful, carpeting ocean floors and shallow waters in bright mats that churned out oxygen day and night. Even though almost every molecule was quickly absorbed, a faint surplus began to linger in the atmosphere, so faint that it could not have supported any breathing organism, but enough to begin tweaking the sky's personality. One of oxygen's earliest atmospheric roles was as a subtle cleanser. When it drifted into the air, it reacted with certain haze-forming molecules, breaking them apart before they could assemble into thick smog. This meant the hazes that once hung overhead began to thin just slightly. Not everywhere, not all at once, and certainly not enough to usher in blue skies, but enough to reduce the atmosphere's opacity. Sunlight filtered through with just a touch more clarity, giving the world a faintly brightened glow. The shift was so soft that only the planet itself could have noticed, a slow drift away from perpetual dimness. Even these tiny amounts of oxygen influenced how sunlight interacted with the atmosphere. Oxygen molecules, when struck by ultraviolet radiation, sometimes split apart and recombined into new configurations. These early reactions produced trace amounts of ozone, not enough to build a protective layer, but enough to start nibbling away at the most intense ultraviolet light. The effect was like placing a thin sheet of tinted glass over a blazing lamp. The world below still received powerful sunlight, but the sharpest wavelengths softened just a bit. With fewer UV photons hammering the atmosphere's molecules, some photochemical reactions slowed, altering the recipe for haze production. This quiet chemical rearrangement changed the sky's colors in subtle ways. The haze particles grew smaller and more dispersed in some regions, allowing a slightly different scattering of sunlight. What had once been a predominantly golden or smoky tone began showing hints, very slight, very delicate, of cooler hues near the zenith. Not blue, not yet, but a washed pale tint that suggested the sky had more depth than before. At sunrise and sunset, faint transitions began appearing, a softer gradient, a gentler edge to the horizon's glow. The sky was loosening its grip on monochromatic tones and beginning to explore nuance. Meanwhile, oxygen continued affecting the chemistry of the air in quiet backstage ways. When it encountered sulfur-rich gases drifting from volcanic regions, It transformed them into new compounds that behaved differently under sunlight. Some of these compounds scattered light more effectively, helping the atmosphere appear a touch less murky. Others condensed into tiny particles that acted as seeds for cloud formation, creating thin, wispy clouds in places where skies had once been completely opaque. These clouds did not dominate the sky, but they added texture, delicate streaks that briefly lit up before dissolving into the wider haze. This period was still far from the great oxygenation event itself, the massive atmospheric transformation that would come later, but it was unmistakably a preview. Oxygen's behavior during these early days was like an artist testing colors on the edge of a canvas before launching into a full painting. Every small increase, every new reaction, every subtle change in atmospheric chemistry served as preparation for the dramatic turning point ahead. The oxygen that did manage to linger aloft also altered how heat moved through the atmosphere. Some gases that had once played major roles in trapping heat were now reacting with oxygen and disappearing. This caused slight shifts in temperature gradients, affecting wind patterns and moisture movement. Clouds formed at different altitudes. Sunlight reached the surface with less distortion, and the atmosphere started showing signs of structure. Layers that behaved differently based on their oxygen content. It was the faint beginning of atmospheric stratification, a feature that would become far more pronounced once oxygen levels rose higher. Marine microbes, unaware of their planetary influence, simply continued producing oxygen at a pace dictated by sunlight and nutrients. But their collective push began to tip the balance. Over thousands and then millions of years, oxygen began outpacing the planet's ability to remove it. This excess, tiny as it was, built momentum, and the atmosphere responded. Its transparency inched upward. Its photochemical reactions shifted tone. Its haze lost a little weight, and its colors gained a hint of softness. By this stage, anyone looking up, if such an observer existed, would have seen a sky that felt more open than before. Not bright, not blue, but lighter, gentler, touched by the promise of clarity. It was the atmosphere giving its first quiet hints that a transformation was coming, driven by the most unassuming force imaginable: tiny organisms producing an accidental gas. Oxygen, still shy, still quiet, had arrived. It was barely whispering, but already changing the vibe. There was a period in Earth's long atmospheric adolescence when the sky seemed deeply committed to the color orange, as if the planet had woken up one morning, discovered fashion, and decided it would lean fully into a bold, saturated aesthetic, no matter what anyone thought. This was the age of methane-rich hazes, when the air was so heavily infused with carbon-based particles that sunlight filtered through in warm, burnished tones. Anyone standing on the surface, if such an unfortunate soul existed, would have found themselves bathed in a permanent amber glow, as though the entire planet were trapped inside a cosmic sunset that refused to end. Earth borrowed fashion ideas from Saturn's moon long before moons were trending. The haze was the result of methane reacting with sunlight high in the atmosphere. Methane, eager to participate in chemical drama, broke apart under ultraviolet radiation and recombined into a host of larger, more complex organic molecules. These molecules clumped together into fine particles suspended in the upper atmosphere, forming sprawling layers of orange-brown smog. These layers were not thin. They were thick enough to sculpt the sky's palette, thick enough to distort sunlight, and thick enough to give the entire world a dreamlike, otherworldly hue. If modern Earth has a crisp blue dome, this ancient world had a dome dipped in honey and dusted with burnt sienna. Under this methane veil, sunlight behaved like a wandering traveler trying to pass through a crowd of dancers who had absolutely no intention of making room. Every photon struggled to push its way through the haze particles, bouncing, scattering, and losing energy with every interaction. By the time sunlight finally reached the ground, it had taken on a softer, more diffuse quality. Shadows blurred around the edges. Brightness dimmed to a warm, muted glow. Even the landscape itself wore this blanket of color. Rocks gleamed with hints of copper. Water surfaces reflected orange highlights, and distant hills appeared ghostly under the filtered light. The atmosphere during this era was not simply tinted, it was sculpted. The haze acted like a giant light dimmer, regulating how much solar energy actually reached the surface. Too thick a haze, and the world cooled noticeably. Too thin, and sunlight surged in more directly. This delicate balancing act played an enormous role in early climate regulation. Methane itself was a powerful greenhouse gas, warming the planet from below, but the haze counterbalanced that warmth by shielding some of the incoming radiation. The result was a climate seesaw, a push and pull between warming and shading, between heat trapped at the surface and light filtered from above. The color of the sky shifted depending on the angle of sunlight. At noon, the world glowed with a deep, warm orange that made everything look dipped in firelight. At sunrise and sunset, the haze thickened along the horizon, turning the sky into a layered gradient of gold, rust, and smoky violet. The effect was mesmerizing if you ignored the fact that it was caused by an atmosphere overloaded with hydrocarbon smog. It was the kind of beauty that belonged on a postcard titled, "Greetings from Primitive Earth. Wish you were wearing a gas mask." Even the clouds took on the haze's personality. Instead of the soft grays or pearly whites we know today, clouds appeared as darker, denser shapes outlined against the glowing backdrop. Some had edges tinged with amber, their tops lit by sunlight that had been tinted on its journey downward. Others blended almost seamlessly into the haze, appearing only as subtle patches of deeper tone. The sky felt less like a dome and more like a layered painting, each stroke shaped by sunlight's struggle to break through. The methane haze also affected visibility. Distant features appeared blurry or softened, not because of fog or steam, but because the haze scattered light in every direction. The world seemed to have a built-in atmospheric filter, a kind of prehistoric Instagram preset designed for maximum ambiance. Even when the air at ground level was relatively clear, the upper haze layers ensured that the horizon always looked a little smudged, a little dreamy, like a memory being recalled through warm-colored glass. Weather systems behave differently under this tinted sky. The haze trapped heat unevenly across the planet, influencing wind patterns and pressure systems. Currents of warm air pushed upward through patches where the haze thinned, creating convection cells that fed into cloud formation. Storms formed, moved, and dissipated with a rhythm heavily shaped by the amount of light the haze allowed through. It was a world where the atmosphere did not simply respond to the sun, it negotiated with it. Chemical reactions within the haze were constant and dynamic. The particles forming its structure continuously broke apart, combined with new fragments, and reorganized into evolving molecular families. Some particles drifted downward, eventually falling into lakes or oceans, where they added fresh organic material to the planetary soup. Others remained suspended for astonishing lengths of time, caught between gravitational pull and photochemical rebirth. The haze was as alive as chemistry can be, restless, shifting, absorbing, releasing, always in motion. As methane levels rose or fell, the thickness of the haze changed. During periods of increased microbial activity in the oceans, more methane entered the atmosphere, feeding the formation of new haze particles. When conditions changed and methane production dipped, the haze thinned, letting sunlight through more easily. This breathing rhythm, a chemical inhale and exhale, dictated atmospheric tone for millions of years. And though oxygen was just beginning its whisper-soft rise in the atmosphere, it had not yet grown powerful enough to challenge methane's reign. The world remained tinted, warm, and dimly lit. It was a sky that felt ancient even as it emerged, a sky fit for a world still deciding what it wanted to become. In those days, Earth looked a little like Titan, a little like a cosmic desert, and entirely like itself, experimenting with identity, wrapped in golds and oranges, glowing with methane-born mystery. A planet still in the middle of its long transformation, dressed in the colors of chemistry rather than biology. Earth's fashion phase wouldn't last forever, but while it did, it was unforgettable. There is something quietly majestic about a transformation that takes millions of years, like watching a sunrise in extreme slow motion. The change is subtle at first, almost imperceptible, but then one day, if you could somehow flip rapidly through snapshots of deep time, you would notice the world glowing just a little brighter. This was the long, patient shift Earth underwent as oxygen-producing microbes multiplied and began tipping the atmospheric balance in favor of a clearer, more light-friendly sky. Bit by bit, molecule by molecule, Earth was slowly opening the curtains after a billion-year nap. The story begins in the oceans, where carpets of photosynthetic microbes spread across shallow waters, soaking in sunlight and releasing oxygen as casually as a tree sheds pollen. Except this oxygen wasn't drifting away meaninglessly. It was accumulating faster than the planet could swallow it. For ages, oxygen had been instantly gobbled up by reactive minerals and gases. But now, those hungry chemical sinks were finally becoming saturated. Iron in the oceans had rusted into vast deposits. Volcanic byproducts had reacted away as much oxygen as they could. The planet's voracious appetite for the new gas was fading, and at last, oxygen began slipping free into the atmosphere like rising steam. With more oxygen circulating, the atmosphere's chemistry started rewriting itself. Haze-forming molecules that once painted the sky in heavy tones found themselves outcompeted or chemically dismantled. The thick methane-built smog of earlier epochs weakened as oxygen disrupted the reactions that kept it alive. The orange curtain that had cloaked the planet thinned step by measured step, giving light new pathways through the atmosphere. Colors sharpened. Shadows grew more defined. Instead of being diffused into a perpetual amber glow, sunlight began slicing through the air with increasing clarity. For the first time in Earth's history, the sun wasn't merely a glowing blot behind the haze. It began regaining a sense of shape. Its edges sharpened minutely at first, like a painting slowly coming into focus. The sky around it shifted from deep, muted tones toward paler, more luminous gradients. The high atmosphere developed a faint transparency it had never known before, allowing wavelengths of light to travel farther and scatter more evenly. Even though the sky had not yet achieved its iconic blue, it was undeniably brightening, carrying a delicate clarity that hinted at things to come. The shift wasn't uniform. Some regions changed faster than others. Oceans near dense microbial communities experienced more significant atmospheric clearing as oxygen poured upward in a steady stream. Inland areas, especially near volcanic zones, lagged behind, their skies still thickened by local gases. But the trend was unmistakable. Wherever oxygen production outpaced its consumption, the sky grew cleaner, lighter, more open. The atmosphere was beginning to feel like a newly washed window, still streaked, still imperfect, but undeniably more transparent than before. As haze diminished, the world's palette transformed. The harsh golds and rusty oranges softened into more natural hues. At midday, the sky revealed hints of brightness that no longer seemed smothered. In the late afternoon, the horizon glowed with warmer purples and reds unmasked by smog, colors painted by sunlight's long journey through a less obstructed atmosphere. During twilight, the fading light shimmered with gentler transitions, the kind that made the planet look as though it were exhaling after an age of atmospheric heaviness. Clouds, too, experienced a makeover. With fewer organic particles dominating the upper atmosphere, clouds formed with whiter, more reflective droplets. Their edges grew sharper, their shapes more distinct. They danced across the sky instead of dissolving into blended haze layers. When sunlight hit them, they gleamed, casting bright reflections onto the oceans below. The world was rediscovering contrast, the visual separation between cloud and sky, between light and shadow, between horizon and atmosphere. One of the most striking changes during this period was the emergence of deeper visibility. Landscapes that had once faded into the haze now appeared clearer across long distances. Mountains stood out against the horizon. Water surfaces mirrored the sky without the orange tint that had long dominated their reflections. Even the air itself looked thinner, lighter, as though the atmosphere had shed a heavy cloak it had been wearing for too long. Meanwhile, oxygen was doing much more than just cleaning up the sky. It was reshaping the atmosphere's physical structure. As oxygen accumulated, it set off a series of reactions high above the surface that began producing ozone. This new ozone layer, still patchy and weak, started absorbing some of the harshest ultraviolet radiation, allowing the lower atmosphere to behave more gently under sunlight. The reduction in UV light changed how gases interacted, slowing some reactions while accelerating others, and further nudging the air toward a clearer state. It was the atmospheric equivalent of dimming a too harsh spotlight so the stage lights could finally do their job. Even the quality of daylight changed. Instead of arriving in warm, filtered tones, sunlight began to feel cooler and cleaner. It scattered in new patterns that made the sky brighter overhead. The world wasn't fully blue yet, but pale hints of that future color occasionally flickered in the right conditions, ephemeral glimmers of a sky practicing for its eventual transformation. And through all of this, the sun itself became a more commanding presence, no longer muffled behind layers of chemical smog. Its light finally reached the surface with a clarity that reshaped the planet's character. It illuminated shorelines, gleamed off microbial mats, and warmed the oceans in more predictable cycles. The sun, which had long been obscured by atmospheric drama, now shone with a sharper personality, as if reintroducing itself after ages of being half-hidden. As oxygen-producing microbes continued to multiply, the clearing of the sky became not just a momentary experiment, but a lasting trend. The atmosphere was pivoting, shifting from a world sculpted by haze to one sculpted by openness. The planet was preparing itself for an age when light would dance freely, when colors would shine boldly, when skies would stretch upward without the weight of smog. Earth, after eons wrapped in shadowed tones and filtered light, was finally waking up. It was a slow awakening, but unmistakably the curtains were being drawn. If you could stand beneath Earth's sky today and show it a scrapbook of its early atmospheric childhood, the sky would probably blush, if skies could blush. It would flip through scenes of firestorms, volcanic ash curtains, methane-orange fogs, lightning feuds, and steam-thick clouds, then glance upward at its present serene face and whisper, "Let's not talk about that." Our modern sky is the planet on its best behavior, pretending it never had a messy phase. But the contrast between then and now is one of the most astonishing transformations in our planet's history, a makeover so complete that if ancient Earth and modern Earth tried to recognize each other on the street, they would probably walk right past without a hint of familiarity. Today's sky, with its soft blue tones and gentle gradients, gives the impression of calm stability. Light scatters through nitrogen and oxygen molecules, producing a color so soothing it has inspired poems, paintings, and at least one child refusing to come indoors. Clouds drift in familiar shapes, cotton tufts, streaks of white, layered sheets that look soft enough to nap on. Sunlight arrives predictably, rising and setting with rhythms humans have built entire civilizations around. It is a sky we trust, a sky we schedule picnics under, a sky that rarely feels hostile. Even during storms, the drama is contained, the theatrics localized. The sky may rumble, but it rarely threatens to remake the entire atmosphere in a single afternoon. This gentle dome, though, descends from a lineage of chaos. If we rewind far enough, we find a world wrapped not in blue tranquility, but in layers of smoke, fire, and chemical confusion. The earliest skies were shrouded in volcanic exhalations, so thick they devoured sunlight, turning days into dim, orange-tinted murmurings. Ash clouds hung overhead like permanent storm fronts, swirling in endless spirals as molten surfaces heaved and boiled below. The air was heavy, opaque, and thoroughly uninterested in letting the sun make a proper appearance. Move forward through time, and the chaos takes a new shape. Meteors rained from above in such numbers that streaks of fire were as common as raindrops. The atmosphere glowed with dust and molten debris, painting the heavens in colors of destruction. Sky and land were siblings locked in a cosmic argument, exchanging blows of heat and stone in a world still figuring out where the boundaries between up and down should be. Then came the age of steam, when oceans struggled endlessly to form. The sky wore cloaks of dense gray mist, wrapping Earth in a sauna-like shroud. Clouds were not gentle shapes, but sprawling masses that refused to part. Light seeped in grudgingly, diffused into soft, ghostly glows. These skies were claustrophobic, pressing down on the world with the weight of an atmosphere still trying to decide how thick it wanted to be. Lightning seasons followed, when the sky crackled like a live wire left in a rainstorm. Electricity forked across the air in relentless flashes, illuminating the world in chaotic stop motion. Thunder rolled so frequently it became background noise, the atmospheric equivalent of endless construction work. The sky was loud, temperamental, and eager to demonstrate its power. As methane hazes settled in later eras, the world was bathed in shades of orange and gold. The atmosphere acted like tinted glass, reshaping every beam of sunlight. Under that warm smog, the sky looked alien. Beautiful, yes, but heavy, mysterious, and clearly uninterested in letting anyone see the true sun. Earth at that time could have been mistaken for a distant moon or planet, its appearance completely obscured behind hydrocarbons, floating like cosmic dust. And then, slowly, the curtain began to lift. Microbial life, quietly multiplying in ancient oceans, started adjusting the chemistry of the air. Oxygen trickled in like a bashful guest, hesitant but persistent, tinkering with haze, shifting colors, and offering the first hints of genuine clarity. As oxygen grew in presence, the atmosphere reorganized itself. The haze thinned, light scattered cleanly, skies brightened. For the first time, the sun emerged with sharpness, rather than being filtered through chemical soup. Over millions of years, this shift intensified. The methane veil retreated, the atmosphere stabilized, and the sun's rays began interacting with molecules in a way that scattered blue light across the dome overhead. Slowly, gently, almost shyly, the sky turned the color we now know so intimately. Earth opened the curtains fully, and the blue world stepped into view. This transformation was not minor. It was monumental. It did not simply brighten the world. It changed everything about how the planet functioned. With clearer skies came more direct sunlight, driving weather patterns with greater predictability. Ozone formed, shielding the surface from dangerous radiation. Photosynthetic life flourished, feeding on the sun and paving the way for ecosystems that would one day teem with complexity. The sky was no longer a battleground of fire and haze. It became a regulator, a partner in Earth's growing biosphere, a stabilizing presence rather than a chaotic force. When we look up today and see that soft, trustworthy blue, we are witnessing the final chapter of billions of years of atmospheric evolution. The sky may seem peaceful now, but it carries within it the legacy of tempests and fire, of hazes thick enough to hide the sun, of lightning storms that stitched the heavens, and of chemical symphonies that shaped the world long before anything walked upon it. And yet, in spite of this wild history, the modern sky presents itself like a model citizen, polished, orderly, serene. If clouds could whistle innocently, pretending nothing dramatic had ever happened, they probably would. Our planet may have had an unruly, fiery, unpredictable youth, but today's sky wears calmness like a well-pressed suit. It stretches overhead, blue and bright, pretending it never had a messy phase, and doing a remarkably good job of it.